What's up guys, my name is Chandler. I am a junior in computer engineering at NC State, and in this video I'm going to be showing you my final project demonstration for ECE306. In this demonstration I will navigate an obstacle course with my car, and at the end my car will detect and follow a black line to complete the course. ECE306 is a class here at NC State that focuses on embedded systems. Over the course of this semester, I have been building the car that you are seeing right now. This car is designed to receive commands over the Wi-Fi and has two infrared detectors underneath it that allow it to detect and follow a black line. ECE306 has definitely been the most hands-on class that I've taken so far at NC State, and I have learned so much from the entire process. On the hardware side, I learned how to solder and connect the different parts of my car into one fully functioning unit. On the software side, I programmed the car's frame board using C, and it was very interesting to learn how my code interfaces with different peripherals on my vehicle. Prior to this class, I had no experience with embedded systems, but having just completed the course, I can confidently say that this class is a fantastic introduction on this subject, and I'm excited to learn more about embedded systems in future semesters. Also, before I get too far into this, I just want to give a big shout out to Professor Carlson and all the TAs for doing a great job adjusting this class to make it work in an online format. So before I talk more about this course and this project, I want to discuss a little bit about how I came to NC State and the experiences that I've had over the past 2.5 years. The reason why I chose NC State was because of its reputation as an engineering school. I truly had no idea what major I wanted to pursue after high school, but I loved math and science, so engineering seemed like a good place to start. In the first year of engineering at NC State, you have to complete a series of baseline engineering courses such as calculus, physics, and chemistry before applying to a specific engineering program. Because I didn't know what engineering I wanted to do, I really appreciated this generalized start since it allowed me to discover more things that I enjoyed and also realize some topics that I didn't enjoy. Additionally, it gave me a year of opportunities to meet with advisors and upperclassmen who helped me choose my path in the engineering program. Through the great resources and people at NC State, I decided on computer engineering and began my major specific classes during my sophomore year. I can't speak for all engineering departments, but my experience with the electrical and computer engineering program here at NC State has been truly phenomenal. NC State lives up to its reputation as an engineering school, with great professors and an outstanding community of students and faculty that help each other succeed. The intro courses for computer engineering provide an excellent foundation for analog and digital circuits, as well as the thought process behind coding. Over the past 2 years, I've progressed from not knowing anything about circuits or coding to building and coding the car that you're seeing in this video. I'm incredibly thankful for my experiences here at NC State thus far, and I highly recommend anyone who is interested in engineering to seriously consider the opportunities that NC State has to offer. So while my car is traveling through the obstacle course, I want to give you a brief overview of what material was covered in this class. One of the first topics of this course is power, which makes sense because electronics are not very useful without it. We learned how the small blue board on the top of the car regulates the voltage received from the batteries in order to provide the 3.3 volts needed to power the system. It was also at this time that we soldered all of the components onto that blue board, including the LCD, or liquid crystal display. These power circuits were very satisfying to work with after having built a foundation on basic circuit design over the past year in various ECE courses. The next topic was about the ports on the frame board. To set each port pin to the desired value, we used basic digital logic, which was taught extensively in previous courses. By setting the values for each port, we ultimately established an understanding of how the port pins related to the car's different systems. Using this knowledge, we built the chassis, attached the motors, and wrote code that gave us control over the car's movements. Prior to this class, I had only taken one course on C programming, so it was very exciting to immediately put all of that knowledge to use. With the port pins properly set up, we shifted our attention to interrupts, which are a critical part of embedded systems. Interrupts are essentially alarms that tell my car to stop what it is doing because there is a more urgent task to be completed. Interrupts provide the foundation for nearly all of the car's functions, and one of the most important functions is timers. Timers give us the ability to make things happen on our time because the code is executed way too fast on its own. Timers also allow us to set up tasks that occur every certain amount of seconds. For example, my car has multiple timers running right now. One timer is constantly updating the display, another is pinging a website to ensure my car stays connected to the internet, and a third is controlling how long my car moves before stopping. After setting up the timers on my vehicle, the next task was to install the infrared emitter and detectors onto my car, and set up the analog to digital converter so that my car could respond to different readings from the emitters. An analog to digital converter, or ADC for short, works like this. The detectors detect a certain amount of infrared light, and the amount detected produces a voltage within the detector. The ADC takes that generated voltage and converts it into a digital value that can be processed and understood by my code. Learning about the ADC helped me see the relationship between analog and digital circuits, two subjects I had previously dealt with in separate classes. The ADC showed me how the real-world measurements, like voltages, are converted into logical values to which my code responds. The final task in this project was to establish communications between my car and a wireless device. To do this, we had to learn about serial communications and how bits travel across the Wi-Fi. Using the Internet of Things, or IoT module, we created a link between our car and another wireless device, like a phone, that could be used to send commands and is currently how I am operating my car in this course. Another very important part of this course is learning how to weave all of these different processes together to ensure that the car could successfully juggle all of the different tasks. We help the operating system primarily through the use of timers that slow down some of the car's functions to allow for time to be spent on other tasks. One example of this is the analog to digital converter. I used a 5 millisecond timer to slow down how often my ADC was getting inputs from the detectors. For those not familiar with coding, 5 milliseconds may seem insignificant, but that just shows you how fast the code moves by itself. The ADC would probably gather hundreds of readings in 5 milliseconds, so the timer allows the code to complete other tasks while waiting for a new reading from the detectors. This concept lies at the heart of embedded systems. It is critical to balance the operating system's tasks in such a way that all tasks are completed as needed. Also, I want to briefly explain the objectives in this obstacle course to give you a better idea of what's going on. The course is divided into two portions, the Wi-Fi communications part and the black line detection part. In the Wi-Fi section, the goal of the course was to travel from checkpoint to checkpoint and display a message indicating the arrival at each marker. Once number 8 is reached, a single command must be given that causes my car to turn, find the black line, and follow it to the circle. Then my car has to traverse the circle twice before exiting and reaching the end of the course. Before I let the rest of the video play out, I can't stress enough how helpful and informative this class has been this past semester. I've learned so much about embedded systems. If you're someone who is interested in engineering but has just become intimidated by this project, don't let that fear stop you. A huge part of this course is simply the culmination of several concepts that have been thoroughly fleshed out in other courses. When I heard about this class a year ago, I was also a little worried about how I was going to gain all the knowledge needed to complete such a daunting task. Fortunately, the ECE department does an outstanding job in laying the foundation in their intro courses, which has given me all the skills and knowledge needed to build this car. NC State's motto is Think and Do, and the Electrical and Computer Engineering department at NC State is a great example of this motto in action. Thank you for taking the time to watch this video. Go Pack!